Okay, so we're going to have a look at another question. This is from the 2022 HSC Standard 2 Maths paper. Now this question also appears in the Advanced Maths paper. So here we're told Joe is researching the relationship between the ages of teenage characters in television series and the ages of the actors playing those characters. After collecting the data, Joe finds the correlation coefficient. So we're told in question 35, correlation coefficient, which we'll call CC, is 0.4564. A scatter plot showing the data is drawn. The line of best fit is y equals minus 7.51 plus 1.85 times x. And the line of best fit is plotted. Describe and interpret the data and other information provided with reference to the context. So this is a rather unusual question. It's a sort of descriptive statistics question. We're asked to look at this line of best fit, comment on important observations, or describe things about the nature of the information we've been given. So first, we can say that the correlation coefficient is moderate. So correlation coefficient is moderate. It's not a completely weak correlation. It's not 0.1 or 0.2. It's not an incredibly strong correlation, 0.8 or 0.9. It's around 0.5. Anything plus or minus 0.1 of 0.5, so between about 0.4 and 0.6, that's fairly moderate. So we've got a moderate correlation coefficient. We have a positive correlation, and we see a reasonable variation in the actors playing actors of each age. So this is certainly noticeable. It is more noticeable for characters age 15 and 17 than it is for characters age 14 and 16, but there is still quite a lot of variation in the ages. If you look at the 15 bracket, you notice that the oldest actors that play 15-year-olds are about 27. The youngest actors that play 15-year-olds are about 14. So there is variation in the ages of actors playing any given aged character. So this is an observation about the data. If we look at the line of best fit, y equals minus 7.51 plus 1.85x, this slope, the 1.85, tells us that for each year older the character is, the actors tend to be about 2 years older. So the slope, m equals 1.85, suggests that actors get older faster than the characters they play, So this is another observation, and they get older at a rate of about 1.85. So if you've got let's say you've got an 18-year-old playing someone 14, you would expect someone who is almost 20 to be playing someone 15, right? Because the slope is about 2. So these are 3 notable observations, and you can make a bunch of small additional observations. So you can say, in addition to variation in the age of the characters, you can talk about the fact that some of those variations are larger, some of those variations are smaller, which group is bigger, which group is smaller. You could plug some values in to the formula. You could state that the line of best fit data may be reasonable for interpolating data for actors between, say, 14 and up to about 18, but anything beyond that, it will not work. So some combination of comments like this will get you the marks. So we're told to provide, the marking guidelines are incredibly vague for this question, incidentally. If you provide some information, you'll get 1 mark. Provide description and interpretation of data, you get another mark. Provide a sound description and interpretation of data plus other information, you get 3 marks. comprehensive description and interpretation of data and other information in the context, you get 4 marks. So just list off a whole bunch of things about the data, talk about the numbers you've been given, talk about the formulas, what do they mean, what do they imply, and then make comments about this data set. This is what's likely to get you full marks.